All right, well, hello everyone, and welcome to the Columbia Memorial Space Center here today. So glad to have you here. My name is Jared. I'm one of the aerospace educators here at the center. So glad to have you all here with us today. And we're going to be talking a little bit about everybody's favorite new Mars rover, Perseverance, which just landed a little over a month ago. So we're going to go ahead and kind of jump right into our little presentation for you here today. So if you're ready for it, I'm ready for it, and we can get it going. And of course, I've got our lovely producer Rick and Sarah with us here today, and we're so happy to be bringing this all to you because it's going to be a ton of fun with it. So let's go ahead and get this started here as we work with our little system that we've got here. All right. So I hope you've been having a really fun time with this. I know that we've been enjoying ourselves, at least watching a lot of the data coming in from the rover and kind of taking that all in and seeing what that looks like. And really, it's just been a massive wealth of information, which has just been so amazing to watch all of this coming down. Um, so what we're going to talk about a little bit today, we're going to talk about Perseverance, the newest, freshest of the Mars rovers that's currently there, and a little bit about the history of Perseverance, its build, getting it to Mars, getting it on Mars, and now that it's on Mars, what has it done so far, and what's it going to do in the future? So to kind of talk a little bit about Perseverance to start, we do have to talk a little bit about Perseverance's precursor, or forerunner, if you will, which is Curiosity. Curiosity was a rover that originally started its design and build process in the mid-aughts, the mid-2000s, and was scheduled for launch for Mars in 2009, but did not make that time frame, did not make that launch window. So it wasn't until 2011 that we finally were able to get Curiosity on its way to Mars. It was a part of what was called the Mars Science Laboratory Program. This was basically to build a literal driving laboratory on the surface of Mars. Curiosity and Perseverance are both about the same size, roughly the size of a small car. We always like to use a Mini Cooper as a nice reference for that. But a Mini Cooper is on Mars. That's a pretty good sized vehicle there. And Curiosity really blazed the trail for that. It launched finally in 2011 and then landed in August of 2012. It is still operating on Mars right now, which is a testament to the amount of engineering effort that the folks at JPL put into making sure that their systems work. It was scheduled only to last about a Mars year, which is roughly 2 years on Earth, about 687 Earth days. But as of today, just checking my little Mars clock, my actual Mars time app that I have on my phone, today is day number 3071 on Mars. But that is specifically a day on Mars, which is not called a day. It's actually called a sol, from the Latin word for that there. And that is because on Mars, days are just a little bit longer, about 40 minutes longer, roughly, on Mars. So they don't call them days, they call them Martian sols. So it is currently sol number 3071 for Curiosity, and Perseverance is fresh and new, still on sol number 36 as of today. And then various spacecraft are there as well, still operating, such as InSight, the lander, which landed in 2018, currently on its 828th sol on Mars. And the two rovers do look very similar to each other. Curiosity has that like classic boxy look with the rocker bogie suspension with those 6 wheels set up that way, and sure looks like Perseverance also has the exact same view over on the right side there, but the similarities pretty much stop at the aesthetics between the two of them. There are some very big changes between the two rovers. Probably one of the most prominent of them, visually at least, is the wheels between the rovers. So Curiosity is doing a very good job with its mobility and driving around on Mars. But the wheels have ended up taking a lot more of a beating than was originally expected by the engineering team on Curiosity, which is fine. Those wheels are designed to be quite broken, as you can see in an image here with that one wheel in the middle. There's quite a bit of material from that wheel missing, to the point that you can actually see through it there. But that is perfectly fine. It is perfectly capable of still driving even with extremely damaged wheels. And it's not so much an issue of this is going to kill the mission. It's more an issue of we would like to kind of have this covered up so that way there's a little more assurance that the mission will actually be okay. So the wheels for Perseverance were beefed up a little bit. So we've got Curiosity's wheels over on the left and Perseverance's wheels over on the right. So we can see a different tread pattern. The tread pattern really has to do a lot with where the rover is landing at, in addition to how the weight is to be distributed across the rover as well. And Perseverance does weigh a bit more than Curiosity does as well. Curiosity was pretty close to 1,900 pounds. Perseverance is a little closer to 2,100 pounds, so just over a ton here on Earth. So you have to kind of distribute the weight a little bit better. And Perseverance has those cleats in its wheels there to kind of help with that, and also to help with traction in what was expected, or what is expected to be a much more sandy, sort of dusty area, as opposed to where Curiosity landed at Gale Crater. So the wheels for Perseverance, they're also a little more narrow, a little bit bigger, and definitely a bit thicker with the aluminum that they're made out of. And they did that so that it could make sure that the punctures that you're seeing in the wheels on Curiosity don't also transfer over to Perseverance as well. And so far with Perseverance, with its very small amount of drives, everything's looking fantastic with it. Now, when it comes to designing and building a rover, you have to be very, very specific about how you do that. It was designed, assembled, built, and tested at the Jet Propulsion Laboratory in Pasadena, California, here in the Los Angeles area. That clean room is there not just to make sure that the spacecraft and everything in it is being made as clean and as nicely as possible. That's there because we also don't want to accidentally contaminate Mars with life from Earth. And every single piece that you see that is going to be going to Mars has to go through a process that prevents it from contaminating. So engineering models like that you just saw being tested, they don't have to worry about that. They don't have to worry about staying clean. But this right here, where this is the actual rover itself being assembled, yes, they do have to maintain a cleanliness that is amazing. And it is a class 10,000 clean room. That means per cubic meter, there can only be 10,000 particles in size. Just to give you an idea of if you compare that to a cubic meter of air like I'm in right now, there's about a couple trillion particles in that there. So this is definitely some very, very nice air in there. And we would joke that the computers inside of that room are probably some of the happiest computers on this planet. And this is them testing a engineering mock-up of a caching system, which I'll talk about a little bit later on Perseverance right there. But this is essentially a system that is going to allow us to take samples on Mars and hold them, and then eventually someone will go pick them up and bring them back to the Earth. So working in these areas, as you can imagine, it is very tough. It's very time consuming, and you have to be very, very careful with everything that you're doing in there. And I always love watching these engineers. They look like little bees in a hive, working around and just trying to make sure that everything is looking okay. And I love the little sort of like plates there on the ground to allow Perseverance to have its wheels touch the ground. And this is the thermal vacuum chamber up at JPL, where they will pump out a ton of air and pump out pretty much almost all of the air, and then heat up Perseverance and cool down Perseverance to make sure it can handle the environment on Mars. Mostly cool it down, because on Mars you're going to find very, very cold conditions. And then watching very carefully, actually driving Perseverance to make sure that all the systems are working correctly. And then eventually you're going to take Perseverance, you're going to pack it up You can put it away, and off to the Cape Perseverance will go. And that's it. That's how easy it is to build your own Mars rover. So I'm sure that you're going to be capable of doing this at home all on your own after we're done with our presentation here today. You are going to need a little bit of money. Perseverance was roughly about $2 billion for assembly and operations as well. So that money is still being spent because there are people still working on it. But money well spent, if you ask us here at the Columbia Memorial Space Center, with with that. And then a very nice thing about Perseverance that you may not know about is how Perseverance is actually powered, how it gets its power. It is not solar powered. Solar power on Mars works pretty well until you have to contend with the dust storms that happen on Mars, and that would be pretty bad. You probably remember the dust storm in 2018 that eventually did in the solar-powered rover Opportunity. Opportunity was designed to last for 90 days, ended up almost going 14 years until finally the dust storm covered up its solar panels. It couldn't charge its batteries anymore, and it basically drained its batteries until it was too cold to stay functional. So unfortunately, you can use solar power, but it's sort of at your own risk with that there. So starting with Curiosity, our rovers started to use what's called a multi-mission radioisotope thermoelectric generator. And this is a nice little expanded view of that there. And basically what it is it is plutonium, not the kind that you would find in a nuclear reactor, but plutonium nonetheless, that is put into an area where there are then thermoelectric modules or thermocouples. These are things that can take heat and convert them into electricity. So as the plutonium decays, it puts out heat, which is then converted by those thermocouples into electricity for the rover to use. And this is fantastic because no longer do you have to have the sun out and worrying about that and losing, your possible power source, or in wintertime, having to park yourself somewhere and make sure that your rover is angled just right, so that way it can get the maximum amount of sun as it's sitting on the side of on the side of a hill there, or wherever you can get your rover to tilt itself at. Now you can just basically sit your rover there and operate it throughout any time of the year. Even with this what we would call RTG, it is able to be used at night. You can use it at night. So that's kind of how it goes with that there. So is that our RTG showing up? Oh no, it's not. It's snacks. Well, it's sort of, if you think about it, with that there. And of course, installing it, you have to be a little bit careful. It's not exactly like it'll go boom or anything like that, but it is definitely something that you want to be very ginger with, I guess is the way I would describe it. I definitely wouldn't be flinging around an RTG all willy-nilly, things like that, but it definitely looks cool. What's great about RTGs is that they're consistent power sources too. The RTGs on Voyager, which was launched in 1977, are still working today. They're still supplying power. Now, you do lose power. It does decay in the amount of power that you get out of your RTG by that time, but ultimately it is a fantastic power source, but it's also very limited. We only have a certain number of RTGs because the plutonium is a bit difficult to make because you do have to have sort of like express permission from the United States government in order to make plutonium of that caliber, of that quantity. And yeah, it can be a little bit of a challenge with it. But once everything's ready to go, it's launch time. So in July of 2019, or excuse me, July of 2020, we actually got to see Perseverance launch. The COVID-19 pandemic occurred the exact same year this was going to be launched, but JPL put in a fantastic effort. There were questions as to whether we actually were going to be able to launch Perseverance or not because of the fact that basically all work had to stop. But JPL was able to figure out how to make it happen. And as JPL does, if you throw a challenge at them, they're going to step up and make that happen. So this is the rocket that it flew on, a United Launch Alliance Atlas V in the 541 configuration. That first 5 in 541 means the payload fairing. That part right there is 5 meters in size. The 4 stands for the 4 solid rocket boosters at the bottom down there. And then the 1 stands for a single engine on its upper stage. So that's the upper stage is called the Centaur. Very reliable, very efficient upper stage that we've been using since essentially the 60s with very minimal modifications. But here was the wonderful launch day when it finally occurred, watching that rocket rise up off of the pad at Cape Canaveral in Florida. And it was a beautiful sight watching that go off. If you never go to a rocket launch, highly recommend it. It is absolutely beautiful. It is a profound experience, both in what you see, what you hear, and what you feel as well, depending upon how close you can get to it. But man, that was very exciting. That was a very early morning for us here in Los Angeles. I think it was sometime around almost 4:30 in the morning for us here as we were watching it. And of course, I believe it was about 20 to 25 minutes before launch, and there's Perseverance separating from the upper stage and on its way. Of course, 20 to 20. I can't remember exactly how much before launch it was, but of course there was a small earthquake that happened in the LA basin that morning. So everybody's at JPL, and all of a sudden it's shaking a little bit. Not a bad earthquake, very small, minor earthquake, but it was still like one of those, oh, I guess somebody was jealous because they weren't getting all the attention kind of moments for it right there. So that was pretty entertaining. So now Perseverance is on its way to Mars. It's continuing on its way. It's cruising. It doesn't have to fire its engines or anything. It's just on its way. There's no air in the way, so you don't have to keep the engines on. You do fire thrusters every once in a while to keep yourself on course with Mars, because you do initially launch your rover not where Mars is, because you want to make sure the upper stage of the rocket doesn't end up impacting Mars. The upper stage of the rocket isn't decontaminated like Perseverance is. The payload fairing and everything there is clean. So it's not like once that pops open, you're exposing yourself to the upper stage. No, you're still very clean in there until it pops open. And once the payload fairing comes open, you're at an altitude that is above the atmosphere of the Earth, about 100 kilometers or 62 miles roughly. So you are certainly not going to be getting much, if any, contamination really at that altitude. Nothing that we know of can survive at that altitude. Not to say that there isn't, but just nothing that we know of presently there. So you're nice and clean on your way. And then eventually it comes to landing day, which was February 18th of this year. And this is a fantastic image here. I absolutely love this image, which was taken by Mars Reconnaissance Orbiter, which is one of the spacecraft that we have looking down at the surface of Mars in very high resolution, and taking imagery for use for missions like this and just general studying of the surface of Mars as a whole. It is extremely powerful with its telescope that it has on board, a telescope that literally aims down at Mars. If you were standing on Mars, we could actually make you out. We could probably determine where you're standing at. I mean, might possibly be able to figure out what colored shirt you're wearing too. But especially once we get closer towards sunrise or sunset with longer shadows, then we could definitely figure out where you're standing at. But this is an image, an oblique image, so taken from the side, a very high side angle, or very low side angle, excuse me, of Perseverance coming down under its parachute. So that's amazing. So Perseverance performs what's called entry, descent, and landing. And entry, descent, landing is a very difficult thing to do on Mars. There is just enough atmosphere on Mars that when you enter the atmosphere at 13,000 miles per hour, you have to have a heat shield in order to survive the heating that you'll experience during atmospheric entry, usually up to about 1,600 to 2,000 degrees Fahrenheit. But there's not enough atmosphere that you can just pop a parachute and then land safely like you can here on Earth. A parachute will get you down to about 300 miles an hour, somewhere in there. So you have to then separate and land propulsively. So basically, you have to use a rocket engine to land on the surface of Mars after you pop your parachute and slow down enough. But the thing is, with Curiosity and Perseverance, they're very big. So you can't take those rocket engines down to the surface. The rovers are so big that the rocket engines have to put out a certain amount of power, and that amount of power kicks up dust and rocks. And if you leave the engines too close to Curiosity or Perseverance, then the speed of that dust and the rocks coming up, being kicked up by the rocket engines, will damage the rovers. And you can't let that happen. And you can't like land them on a structure, because that could easily tip over, and the rover could also tip over on the structure as well. And you don't exactly want to have your $2 billion rover accidentally flip. That's bad. So they decided to come up with this system called the Sky Crane. And we're about to take a look at it. So let's go ahead and take a look at landing on Mars.
And fly right maneuver, where the spacecraft will jettison the entry bound.
So actually, before I officially start it, let me just say that these are real views from actual cameras that were on board of Perseverance for the landing. This is the first time that landing on Mars has been filmed in this much detail. Curiosity had a very small camera on the bottom of it called MARDI, which is the Mars Descent Imager. It took 4 frames per second. Not exactly what I would call great footage. It was amazing to see it though, because you were like, oh my gosh, this is actual landing on Mars. But this here, we're seeing actual imagery in real time from Mars, both of parachute deployment, of the heat shield popping off, separating so that it comes out under the rocket-powered pack, lowering on the cables for the Sky Crane maneuver, and then dropping Perseverance off on the surface. So for this first run through, I'm going to be quiet, because this is still mind-blowing even to me. And I've watched this probably 100 times by now. So
we are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Operator indicates chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 480 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converged. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers of the surface. Perseverance is continuing to descend on the parachute. We're planning upon the initialization of terrain relative navigation and subsequently the timing of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OBS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Timing. CPA is nominal.
We have timing of the landing engines.
Backtail set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the backtail has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Here in safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane. Let's conduct the sky crane maneuver. Sky crane maneuver has started. About 20 meters off the surface.
Getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of the Venus, ready to begin seeking the sands of past life.
So that was certainly one of the most amazing things that I at least have ever seen. And being involved in engineering for almost a decade, I think that says a lot because I've seen a lot. But that is just amazing that they were able to get this incredible view, seeing the parachute deploy right there and comparing it to the exact same imagery that would be coming in those videos that we saw of parachute tests, and seeing that heat shield separate, and you can actually see pieces of ice there that had likely built up during the cruise to Mars, and then finally once the heat shield separates, and the rover is experiencing air, if you will, the atmosphere of Mars for its first time, ice falling off. And there's lots of pyrotechnic devices that fire, and I'm sure that those definitely jostled the ice that's going on there. And now we're seeing the parachute as it kind of wiggles under, or kind of is back and forth under the parachute here. And I'm sure that would not be pleasant for most people with something like that. But we're also getting to take a look at the landing site here too. This is being used not necessarily just to confirm engineering analyses or things like that. This is also being used as actual scientific data for geologists and other mission scientists to determine where they actually want to drive Perseverance now that it's on the surface of Mars. So it's been amazing watching all of this coming down. And this is something that has been in the realm of animation. So we have only been able to see something like this in computer generated animations, but now we actually have the footage of what it really looks like to go to Mars. And that's just astounding to think about. You're actually watching yourself land on Mars here. I always love the separation. There we go, right there. And the rocket pack the descent stage immediately just pops off. And because it's getting ready to slow down, it doesn't want the back shell with the parachute to smack into it. So it does that hard divert maneuver and then comes around. And then the terrain relative navigation, which is a brand new system that uses cameras on board of Perseverance that are looking down to figure out safe places to land, looked down and attempted to figure out a safe place to land, and did a very good job of that. And then finally we're coming in and we're seeing that altitude hold as it's determining for the final height, when should I start dropping Perseverance. And then finally over on the left side you get the up look camera on top and the down look camera on the bottom, and you're seeing the descent stage in that top view, and then Perseverance, the multi-billion-dollar Mars rover, sitting on the bottom. And then I'm finally seeing that bridle holding the two cut, and then the descent stage head off. Its job is done, so now it shall go and crash elsewhere instead of on top of the rover. So absolutely astounding. I was doing the exact same thing these folks were, not only during landing, but also during the viewing of the footage when it came back. So one thing I really would like to emphasize about the Sky Crane with this here is that this is not a system that can be tested on Earth as a whole. You can test bits and pieces of it, but you cannot test this whole thing together. So when this came up with in the mid-aughts, many people looked at the engineers at JPL and went, you guys are out of your minds. Why you can't do this? And then JPL basically had to convince everybody, yes, not only are we out of our minds, but we're out of our minds in the right way. We're looking at this problem, we're figuring out how to solve it in the simplest possible way. And that is where the Sky Crane comes from. It does look wild and absurd, but I assure you that, having heard from many people at JPL, it is the best system that they could think of to land heavy things on the surface of Mars. And Perseverance is about as heavy as it gets with our current technology of landing things on Mars. And it just blows my mind that the people who worked on this Skycrane landing system have spent half a decade not knowing what it actually looks like. And now they finally got to see what this thing they designed actually looks like when it's at work. It is so rare in engineering. It's almost never heard of for right out of the gate to basically say, this system, we have not been able to test this whole system together, but we're going to throw it all together and see what happens on its first use. So again, JPL is, as they often describe themselves, the right kind of crazy, and I can't help but agree with their assessment of themselves with that there. So SO is asking, was sound recorded? So we'll get to that in just a little bit. So not only were those amazing views being done at the same time, there's also supposed to be sound recorded because Perseverance has 2 microphones on board. One is going to be used strictly for entry, descent, and landing. The other is being used for essentially driving out and about and just the ambiance of Mars and other things like that. As was mentioned at a press conference, unfortunately, the audio when it was being recorded during the entry, descent, and landing did not make it from the microphone to the hard drive on board or where it was supposed to be recorded. They think they might have overwhelmed the pipe that was sending the data there. So unfortunately, we did not get audio of entry, descent, and landing. So I guess we'll have to wait for the next rover to do that. But we'll talk a little bit about the first sounds on Mars because Perseverance has recorded sounds on Mars, and we'll absolutely listen to them in just a second here. So from one amazing first to another. So over the course of a 450 million kilometer journey, roughly 300 million miles, Perseverance landed 1.7 kilometers or 1 mile off of the center of the target that they wanted it to land at. So 300 million miles and you land 1 mile off of where you want to be at. That is precision that I don't think anyone can rival. And in addition to that, the terrain relative navigation, which is a system that basically keeps Perseverance safe, but still allows it to fly into places where it is scientifically interesting, did a fantastic job. This is a map of the area where Perseverance landed at. And basically, the 2 colors you see on this map, red and blue, correspond to red. If you land here, that's it, game over, done, mission over. You've finished the mission on landing. Blue is you're good. You can land here. This is a safe place to land. So red is dead, blue is good, and you can see that terrain relative navigation basically nailed it. The red does not mean that Perseverance cannot go to these places now that it's on the surface, but the red means that if you tried to land there, something was going to happen. Something was very likely going to happen to Perseverance that would do it in. So again, JPL just nailing it as they always do. And yes, Jezero Crater, where Perseverance has landed at, is an absolutely amazing place. Just looking at it, it is an area where water from a river flowed in. So basically a river delta on the surface of Mars. And what's so significant about that is that in river deltas here on Earth, we find tons of life. They're just teeming with life. And one of the things that Perseverance is trying to do is to find life and find at least past evidence of life are very strong or indicators, strong indicators of past evidence of life. So going to a river delta, a former river delta on another planet is a pretty good way to do that. And we'll kind of get an overall view of Jezero a little bit later. That'll you'll definitely look at that and go, oh, I could see where the water was flowing. But the images that were coming down initially from Perseverance were fantastic. Just seeing that we landed this rover sort of in a relatively rocky area, not as sandy as expected or soft as expected, but still not an issue for Perseverance to be driving around at all. And one of the things that Perseverance is there to do that I hinted at earlier is it's there to take samples of Mars, and not just for study in the systems that are on board of Perseverance there, but to basically grab these rock samples and put them into containers, seal up those containers, and then hold on to them until at some point during the mission, they decide, you know what, this is a good spot to put these containers. We're going to put them down right here. And then 5 years down the road, another mission is going to come, deploy a rover, pick up the containers, put them in a small rocket, and return these samples to Earth. So Perseverance isn't just there to try to find good, solid, potential evidence of the possibility of life having been on Mars. Perseverance is also the opening round of a Mars sample return mission, which a Mars sample return mission is essentially the planetary geology holy grail. The Ark of the Covenant, if you will, the knowledge that everyone has wanted to have is the ability to take Mars and bring it back into a laboratory here on Earth and do exactly what those rovers are doing, but it's so much better quality than what they can do. The joke is that what takes a Mars rover 10 years could be done in a laboratory on a college campus in 5 minutes. And that's pushing it a bit with, with the capabilities there. But also, it just goes to show that here on Earth, our instrumentation is just so much better than what we can put on another planet. We can do our best to try to put the best stuff on another planet, but nothing beats bringing it back to a laboratory here on Earth. Just as an example, the samples that we still have from Apollo that we're using to study the moon, we're still making new discoveries with those, 5 decades later. So yeah, that's how important having an actual sample on your person here on Earth is. And we just got some more moon back from a mission that China did, their Chang'e 5 mission. No word on if anyone in the United States is going to work with China to get any samples or anything. That's sort of up to universities if they would like to do that. NASA is actually, by an act of Congress, legally not allowed to work with China, so they have to follow those laws. But also, the Japanese Aerospace Exploration Agency, JAXA, recently returned material from asteroid Ryugu on their Hayabusa 2 mission. And then NASA has the OSIRIS-REx mission, which is currently inbound to Earth to drop off its sample in 2023 of asteroid Bennu. So that's going to be very exciting when we get that. So hopefully we get some pieces of Mars back by the end of this decade. That would be very, very exciting. It will also be the most complex, most difficult mission ever attempted, and probably one of the most expensive, if not outright the most expensive mission ever. Talking multi-billion dollars, in excess of $5 to $10 billion easily out the door, because you have to fly a spacecraft to Mars, you have to drop down a system onto the surface of Mars to grab the samples, you have to have a rocket on Mars to launch the samples back into orbit so they can rendezvous with that spacecraft, and then that spacecraft has to be able to get back to Earth. It is so wild, the engineering that has to go into that. I can't even begin to talk. I can't even begin to scratch the surface of the complexity of that. I figure we could probably do an entire Space Center live about sample return and just how difficult it would be to do something like that with Mars. But this is it. This is the beginning of Mars sample return. And they did have a cover on there. And now that it's on Mars, they just went ahead and dropped the cover. So what do we do on Mars? We tend to litter everywhere we go. So it's not just a thing we do here on Earth. It's also something that we do throughout the solar system. So now I want to talk a little bit about the sounds of Mars, because there are microphones on board. So let's go ahead and listen into some of the JPL engineers as they talk about that.
I invite you now to, if you would like to close your eyes and just imagine yourself sitting on the surface of Mars and listening to the surroundings. If I could have the first one, please. So that gentle whirl that happens in the background, that is a noise made by the rover. But yes, what you did hear 10 seconds in was an actual wind gust on the surface of Mars, picked up by the microphone, sent back to us here on Earth. The analysis indicates that was around a 5 meter per second type of wind gust. So we can sit here now and actually tell you that we have recorded sound from the surface of Mars. So we have a second one, which basically further reduced the noise of the rover, so you can just hear what the wind would sound like on Mars. And once again, I invite you to sit back and have a listen to what it would sound like to be on Mars. It's cool. Really neat, overwhelming, if you will. I can't remember what I was going to go and say next.
So as you can imagine, being an engineer and hearing that, it's probably got to be absolutely amazing. That had to have been absolutely amazing to hear that for the first time, knowing that you were one of the first people to hear the sounds of Mars. You probably heard before recordings from InSight from its seismometer with winds of Mars and things like that. But that's from a seismograph. That's not an actual audio recording. So these are the first real audio recordings on the surface of Mars, which is very exciting, just because it's never been done before. So this right here is where Perseverance landed at. The landing area was named after Octavia Butler, the late Octavia Butler. Very fitting, if you ask me, to name that. After all, we are Earthseed, and it's a fantastic tribute to her. And when we go in and we look a little bit closer at what's going on with Perseverance, there's two possible directions they're thinking about taking Perseverance. It may go to the north in that blue direction that you see right there, head over to a crater and kind of mosey its way over. And then it may actually go south at that purple line that you see right there, kind of going down and around and taking a look at everything there, and maybe spotting a little ridge and seeing what that looks like. But eventually the goal is to get to that yellow line right there. That yellow line is going to take it right into the river delta that you see right there. So Belva is a crater that has formed after the water has dried up from that delta. So you can see that it is incredibly strong evidence that water was flowing there in abundance, in massive volumes at that time. So this is very exciting because the Perseverance landed pretty much exactly where it needed to land at in order to start doing the science it had been sent to do immediately. And they're going to send it off to Neretva Vallis over there and see what eventually comes of that. But for now, the goal is essentially just kind of continue to have the rover do what it needs to do. And we always love photos like these. I like to call these photos the scene of the crime, because this is taken by Mars Reconnaissance Orbiter, kind of showing you again the ability of Mars Reconnaissance Orbiter and its incredible Mars Orbiter camera system that it has on board. That camera basically attached to a telescope designed to look down at the surface of Mars. We can see over on the right where the heat shield eventually impacted. You can see over on the far left where the parachute and back shell landed at. I believe we've been able to figure out that the back shell actually landed upright. So if anybody would like to, there's a nice back shell and parachute sitting on the surface of Mars right now. Maybe we could put it on Craigslist for, I don't know, what do you guys think, $125 million? OBO, it's got a clean title and everything, so it's good. And then we could see in that middle left one right there, the smear, the leftovers of the descent stage. So yes, the descent stage went all the way to Mars just to crash. So very sorry, descent stage. I shed a tear every time thinking of it. But let's face it, the descent stage had probably the coolest part of the video ever, which is seeing it work there. And then down in the middle right there, Perseverance just chilling, hanging out at Octavia Butler Landing. So yeah, very, very exciting stuff to see with what they're doing out there. And now let's get into the instruments, the real reason for the rover being there. And there is a lot of instruments that are on Perseverance here. We're going to sort of highlight some of the ones that are very exciting, because some of them, like the drill and the caching system, we've already talked about. The laser retro reflector, I think it's pretty. I think that speaks for itself. Once there's a laser in orbit, it can bounce back up and help with ranging systems. But I want you to take a notice too that there's flags from different countries here. Mira is from Spain, SuperCam. We've got France and Spain there, our laser retroreflector, Italy. So this is not just this is not just the United States working on something like this. This is a actual, this is a real international effort in order to do something like that. And to kind of talk about that, one of them is this. This is RIMFAX. And RIMFAX stands for Radar Imager for Mars Subsurface Experiment. And what this is a ground penetrating radar system. And this comes from Norway, by the way, from the University of Oslo. So very, very exciting that they have that there. And it's basically a ground penetrating radar. It's going to be able to go down about 10 meters, about 30 feet at first, although they're going to tune it and see if they can get it to go a bit deeper. And it's going to be able to take images about every 4 inches, about every 10 centimeters along the track that the rover drives. And it will show us what the subsurface is like. It'll show us layers, or we may find layers, or we may not find layers, or maybe it's just one big thick layer in that particular area. We may find rocks, we may find a layer of rocks. I mean, it's kind of anybody's guess right now as to what the subsurface of Mars is really going to look like, simply because there's been no radar, no ground penetrating radar actually put on the surface. There's been plenty from above the surface with orbiters, but they're like hundreds of kilometers, hundreds of miles above the surface, not, like 2 feet. So this is pretty exciting. I can't wait to see what they're going to be doing about this one, because it should be able to detect water and ice. So if there's water ice down there, we'll know it. If there is salty, briny water underneath in its liquid state, we'll know it. And RIMFAX will actually tell us about that. Just by the way, just to remind you, RIMFAX, because of course it is from Norway, they did a little backronym to try to make it sound like Rimfaxi, which is the horse in Norse mythology, which brings the night, which is the grandmother of Thor. So those of you who love Marvel movies, you guys should definitely have been able to figure that one out quite easily, right? So our next one is called SuperCam. And SuperCam is being done, is principally investigated by the Los Alamos National Laboratory. This is basically a system that looks at rocks and soil and fires a laser at them, and then looks at the light from the laser. As the laser hits the rock or soil, it vaporizes, so it turns little pieces into gas because it gets so hot, and it can read those gases and figure out what's a part of those gases and what makes up those gases. So that's pretty exciting. What's great about SuperCam is that you can actually pinpoint something as small as a pencil point from 20 feet away. So if you see a rock in an image and you're like, I really want a sample of that, you actually don't have to go up to it. You just shoot it with SuperCam. And what's very, very cool is that they have audio recordings of SuperCam firing with its test ones. And it sounds like a clicking of a clock, because it's just consistently firing with that there. And I think what's so cool is that the science team on SuperCam says that it's not just the vapor coming off of the rock that they're going to be able to analyze. It will also be the sound of the laser hitting the rock. They're going to be able to listen to that sound because we have a microphone now. We can record the sound. So they're going to record the sound of the laser hitting the rock, and they're going to be able to determine things about that rock, like density, composition, and other things, just from the sound of the laser hitting the rock. I had no idea you could do something like that. That is ridiculous, and this is why I love stuff like this. This right here is META, which is a meteorological experiment from Spain. This is a great experiment because there was a similar experiment on Curiosity that got damaged during landing because of the thrust from the engines on the descent stage as it was lowering it. So this is sort of a new one, sent a much more improved to work with that there. And it is going to measure the weather on the surface, which is really cool, and also dust and other things like that. And actually on let me see if my Mars app has it. There are some apps out there that you have that actually can give you weather reports. So unfortunately, actually, yes, here we go. Okay, so current weather on Mars. Don't know how well you can read that there, so I'll just read it for you. This is from Curiosity, by the way. So current weather, latest weather update from Mars for all of you. Sunny, minus 41 Fahrenheit. Today's high will be minus 10 Fahrenheit with a low of negative 74 Fahrenheit. No winds at the moment. And the ground temperature is about minus 34 degrees Fahrenheit. So getting data like that tells us a lot about the planet and what's going on Mars and other things like that. So it's very, very exciting for us to be getting that kind of information from them there. And Spain, wonderful instrument from Spain as well. The next one is called Pixel, which is the planetary instrument for X-ray lithochemistry. So we'll be using X-rays to actually make determinations on compositions of things. This one's very excited. This one is from NASA JPL. So this is the Jet Propulsion Laboratory, their own instrument that they're working on there. Basically, it looks at rocks in the soil, and it's able to identify chemical elements at extremely tiny scales, near microscopic scales. And it can see things that are about the size of a grain of salt. So taking chemical composition of things at very tiny scales and very, very small areas with very high resolution, something that hasn't been able to be done on there. And this one is called Sherlock. And this one's also being ran by the Jet Propulsion Laboratory. This stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. Boy, if that isn't a backronym, I don't know what is. By the way, there is a color camera that also works with this. And guess what they've called it? Watson. So yes, this instrument is Sherlock and Watson working together. Essentially, what this is, it uses cameras and spectrometers and a laser to measure organics and minerals that are in these areas. And it is specifically minerals and organics that may have been altered by water or potentially past signs of microbial life. So if the signs of life are going to be found, it is going to be this instrument right here that does it. And then finally, this instrument, which is the one that a lot of us are very excited about, comes to us from the Massachusetts Institute of Technology, MIT. Hey, who says that Caltech and MIT don't work together? Look at this. On a mission from JPL, which is managed by Caltech, you have an instrument from MIT. How great is that? This is Moxie, the Mars Oxygen In Situ Resource Utilization Experiment. And basically, this instrument is going to take in take in Mars's atmosphere, which is mostly carbon dioxide, and convert it into oxygen and see if it's got the Moxie to do that. This is very important because when we send humans to Mars, we cannot take all of our equipment with us, or we cannot take all of our resources with us, such as like oxygen or water or other things like that. So we need to have some on Mars, and we need to learn how to make some as well while we're there. So that is the goal of that there. And of course, Ingenuity, the Mars helicopter, it just had its cover removed the other day. So they're getting ready to deposit it down to the surface of Mars in just a couple of days. And they'll unfold it and then drop it and move out of the way. And from what I understand, towards the beginning of April is when they're going to actually attempt to fly Ingenuity. By the way, the official nicknames, if you want to, Perseverance is known as Percy, if you just want to cut it short. Ingenuity is known as Ginny, if you just want to cut it short as well. So Percy and Ginny out having a good time on the surface of Mars. So quite enjoying that. Little nicknames that they always give our delightful explorers out there. Now, there are some things besides the instruments that are also on the rover. A aluminum plate with the serpent staff for medicine, for the world of medicine, was added on to Perseverance to sort of mark the COVID-19 pandemic and honor those who are working to speed up a solution to it, and also those who are working with the folks who are affected by it as well. So we could see that the staff, along with the Earth right there with a vehicle heading from Florida off to Mars. So that's there to remember all of those working on it and affected by the COVID-19 pandemic. But you may have been able to be one of the nearly 11 million people to send their name to Mars. And if you are one of those people who signed up for that and online and sent your name to Mars, those 3 microchips right there are where your name is at. So it's about 10.9 million names on those 3 microchips right there, kind of showing off where it's at. That's on a sort of like suspension sway bar on the top deck of Perseverance there. In addition to that, when we look at the top deck, there was another little Easter egg that they didn't tell anybody about that they ended up doing, and that is over in the middle left right there. You can maybe just barely make out those some sort of little scratching on that metal part right there. Well, if you look a little closer, yep, they put images of all of the rovers on there. The names are not there. Those names are there simply to help us identify them. But yeah, they literally have the little, I guess, glyphs of each rover that JPL and the United States, and frankly, basically every rover that's ever operated successfully on the surface of Mars is, starting with Sojourner from 1997, Spirit and Opportunity in 2004, Curiosity in 2012, and now Perseverance with a little tiny Ingenuity off to the right of it right there in 2021. And just to, I guess, confirm that JPL really are the biggest nerds in the solar system, you may have heard that there's a secret message in the parachute of Perseverance. And guess what? There is a secret message in there. So the inner portion in this here spells out dare. The middle portion says mighty, and then the outer inner portion says things, and dare mighty things. That's JPL's sort of official motto. And then the exterior of the parachute there is the latitude and longitude of JPL. So I guess they wanted to drop both the motto of JPL and where to return the parachute to at some point on the surface of Mars. So that way, if anybody comes across it, they'll know exactly where to take it back at some point. And in addition to that, I just want to say the internet is amazing because within several weeks of that, there are already Dare Mighty Things, skirts and umbrellas and other things such as that. So get your merch on, I guess, with stuff going on like that. And Perseverance is now starting to drive across the surface. It's starting to get its wheels dirty and really beginning to actually start the science in just about a week or two. Instruments are being qualified, they're being tested, they're being made sure that everything's working and looking good and kind of working with that. And really, I just kind of wanted to end it right here on this amazing image of Perseverance hanging underneath the descent stage as it's just feet above the surface of Mars, because this seems like a really good way to summarize us as humans, because we're explorers. We love exploring, and we just can't get enough of it. We just, everywhere we want to go, we want to know as much as we can about it. And this to me really epitomizes that. Us overcoming every challenge that we can, whether it be an engineering challenge, whether it be a materials challenge, whether it be a global health challenge as well that we had to contend with in putting Perseverance on the surface. We're up to it. Us humans, when we get together, we end up doing amazing things. And as I always like to say, space brings out the best in humanity. It demands the best of us, the best of our understanding of a multitude of things: physics, mathematics, materials, engineering, cooperation, and teamwork. Everything that space requires, it requires the best of humanity. So that's why I always love space. And that is our little talk that we have about Perseverance today. So if there's any questions, we can kind of hang out a little bit with it. I think SpaceX was supposed to do their Starship or SN11 hop today. I don't know if they did it or not. So I would figure that would be one of those things I would know about pretty quickly. We can always, check the internet very quickly if that occurred. Okay, let's see. Nope, they're going to wait till Monday to hop it. So, okay. So, cool stuff. So that's pretty cool. So if there's any questions, we're definitely now open for it. especially now that we know there's not a Starship hop to run off somewhere else to. With that there. So, by the way, it was a tweet from Elon Musk, by the way, saying that they're going to push till Monday. So, I figure if anybody knows anything about SpaceX, it's the guy who is kind of sort of at the top of SpaceX there with it. But hey, cool stuff. And then again, Perseverance laying the groundwork as well for stuff that companies like SpaceX are going to be doing someday. Taking humans to Mars. You want to know about that resource utilization and know if you can use Mars as a resource for that. So very exciting for that. So if any questions, feel free to ask. If not, we can always wrap up a little early, and that's okay. And do want to remind you that tomorrow is City of STEM. We are having our massive science festival once again virtually this year for all of you to enjoy here. You're going to want to head on over to youtube.com/City of STEM, STEM, for that. It's going to be really exciting. I'm excited for it. There's going to be a ton of people at it. I think we got Garrett Reisman, who's a former NASA astronaut, and was quite involved at SpaceX as well. Just like everybody you can think of is going to be there. I think. Are we having Bill Nye this year? And if I remember right, Kareem Abdul-Jabbar as well. Bill Nye and Kareem Abdul-Jabbar. You got a bow tie and like the greatest basketball player of all time. I said it. So yeah, that's at the same time. Holy moly, you guys are kidding me. I can't. I don't know if I can handle that. That's a lot. That's a lot for me personally to handle. Being a basketball fan and science fan. That's like my childhood all wrapped up in one. Bill Nye and Kareem. So I'm super excited about that. So hope to see you tomorrow. It'll be at 10 a.m. Pacific time. That's when it'll start. It goes to 5 p.m. Pacific time. So if you're like, oh, man, I don't want 1 hour of science. I'd like 7 hours of science, not 6, not 8, but 7. You're in for it tomorrow. Let me tell you, it's going to be excellent. I don't know who that was, but they quite like the idea of 7 hours of science going down. So yeah, so very, very excited about that. For all of you who live on coordinated universal time, that would be 1700 UTC to 40 UTC or midnight UTC. So should be a lot of fun tomorrow. And again, I gotta say, Garrett Reisman, Bill Nye, Kareem Abdul-Jabbar, you name it, everybody's gonna be there. Wow. That's just mind-blowing to me that we got Bill Nye and Kareem Abdul-Jabbar in the same place at the same time. Once again, just to remind you, that's all going to be taking place on youtube.com/City of STEM, CITYOFSTEM. That's right. We can spell here, not just the math. We can also spell here at the Columbia Memorial Space Center. So I think on that note, reminding you once again, the City of STEM tomorrow from 10 a.m. to 5 p.m. Thank you so much for stopping by our Space Center Live. We're going to be making a very exciting announcement for our next one, which will be happening on April 9th. We're going to be talking about the 40th anniversary of the first flight of a Space Shuttle Columbia STS-1. We're going to go into that mission in detail. And if that wasn't enough for you, we're also going to be talking about the 60th anniversary of the first space flight ever. Yes, Yuri Gagarin's flight into space. And that's because on April 10th, we're also going to be a part of Yuri's Night, a global party celebrating humanity going into space. So once again, folks, thank you so much for stopping by us here at the Columbia Memorial Space Center. And we hope to see you soon. And everybody stay safe and keep exploring.